Okay, welcome to this video to wrap up the sort of lecture materials for Lab 2, dealing with the material science and testing of concrete. This video will touch on just the concept of standards and standardized testing methods, and focus primarily here on the American Society for Testing Materials, ASTM, and some of sort of the functions and logic of standardizing materials and test work this way. Okay, so you can see here that the American Society for Testing and Materials, as listed on their website, provides a forum for the development and publication of international voluntary consensus standards for materials, products, systems, and services. So it is a resource that engineers and manufacturers often turn to before deciding to come up with their own test work that may not be more universally accepted. So a good resource for most manufacturing and engineering industries. And so we'll start with just the idea of what a standard is. So here's sort of the idealized definition of a standard. So in this context, it's a document developed and used by consensus of the stakeholders, which describes how a product is to be obtained or used. So in the context of developing a test method like a slump test, the stakeholders would be all those involved in considering the use of concrete. The product is, of course, the concrete, ultimately, and the document here is going to help us understand how to conduct the slump test. And so we'll see an ASTM towards the end of this video. And it's ultimately a focus of our Labster simulation for Lab 2 for Material Science 410. So what does it mean by a document? This could be a hard copy paper version, or more common these days, an electronic version. The stakeholders, as we mentioned, includes anyone with an interest in the material without restriction. So we can even move past those of the engineers or manufacturing or construction folks working directly with concrete, but anyone interested in the test work there is a stakeholder. The product can be elaborated generally past concrete, and this could include hardware, software, analysis results, test results, protocols, definitions, lots of options there. And what is it that can be obtained or used? Well, this can mean something that is being designed or built, procured, calculated, or even tested. So considering a standardized method for measuring slump is an important concept for concrete, and it's going to be part of our investigation, as we mentioned. So what are the features of an ideal standard, therefore? So clearly, whatever we come up with better be relevant and necessary. So the idea of measuring the workability of pre-cured concrete better be relevant. So clearly it is, because it affects how we can process and handle the material, as we mentioned in earlier videos, for, say, pumping to mechanically lift the material to a different level for pouring and setting high-rises, for example, in buildings. The ideal standard should be singular, so it should focus on a specific concept. So if we consider a slump test and an ASTM for that, we're going to see that largely focuses only on that test method and the sort of steps to do so, and not elaborate into other areas or topics. And it should be unambiguous, so it should not be subject to multiple interpretations. It should be very clear and understood what can be done. And this allows for consistency, which means that it will not conflict with other documents in the same family of standards, and will allow it to be a universal method. And lastly, the method should be auditable and measurable. So we should have quantitative exit criterion showing that the standard was followed. So there should be, in the case of a slump test, you can see here that the criterion and the steps to do the test will allow for a standardized numerical or metric for the amount of slump that occurs. So in general, Some types of standards include technical terminology, materials specifications, process specifications, test methods, as we've emphasized in this video. Test fixtures even have standards. Data reduction methods, data reporting formats, test matrices, statistical procedures, analysis methods, and many others can exist. So this ASTM, as we mentioned before, generally is recognized to have 5 specific types. There can be specifications. So this is in the sense of procurement of a document. There can be test methods. So this can produce a test result, as we focus on here in the slump test. An ASTM can actually provide terminology or definitions. It can actually provide practice as well, so a protocol that doesn't necessarily produce a test result, therefore. And lastly, it can provide a guide. So it can be informational. It can be an informational description of a number of options, for example. So I invite you to kind of learn more at the ASTM.org website to sort of see how this society might serve you as you consider testing and other materials in your future careers. As we mentioned in this lab, we're interested in a slump test focused on ASTM C143. And so here you see the beginnings of this listed here. And so here's the document shown here for us. And this is going to outline very clearly the sort of structure for the cone that shapes the pre-cured cement. And it's going to allow us to sort of ensure that it is sort of tamped and filling that cone appropriately. Upon removal of that cone, slump will possibly begin, and this ASTM is going to define sort of the time one waits for the slump to progress, and ultimately the method for measuring sort of the amount of slump that has occurred over that 60-second period. Okay, so a good document like C143 will list all the specifics here to ensure that this is a universal and reproducible test method, and many other ASTM documents exist for many other types of test work, and I invite you to search their database as you consider other test work in your careers. Okay, and so just touching on briefly what you'll see in the simulation is that we will be considering various sort of powders that form aggregates, and we'll be looking at the aggregate kind of qualities and characteristics that can be kind of defined by using sieves to separate those aggregates into fractions with a certain size. And so this will allow us to kind of test out different types of formulations of concrete, and ultimately we will use our cone for the slump test listed here, rod for sort of ensuring that it's properly filled, put that on a proper test surface listed here, and using a standardized kind of ruler here to help us understand the amount of slump that occurs over a time period listed in the simulation. Later parts of the simulation emphasize other materials that you've covered in prerequisites for the course. So here you'll go through a simulation for a compression test where you'll look at the force versus deformation and ultimately fully fail the material until there's a crack developed, as you see here in the specimen. And this will allow for comment on the mechanical properties of a cured concrete arising from the fractionated aggregates studied in this simulation. And that will complete the most of the simulation work in this lab. Hope you'll enjoy it, and please reach out to me if you have